All right, this is the next project. We're back on the lathe, giving the Camaro a little break. So we have these plastic pieces for this RC car. You can see the RC car probably on the RC Renegades YouTube channel. But these are the plastic pieces, the stock ones. And what happens is the shell, which I'll show you once everything is going to go back together with the new pieces, the shell can't go all the way down because it's there's not enough clearance with all the battery and the motor and the fans underneath. So what I got to do is I got to make these longer and make them out of aluminum so they'll be a little bit stronger, so we can clearance the shell away from all the mechanical bits of the RC car. So I've just finished taking my measurements of the stock plastic piece, which you see here, and then I have my upgraded aluminum piece measurements. And basically this piece here is going to sit on this little aluminum piece, and we want it to, this is our through hole, so that when this sits on there, it'll thread in from the bottom. And these are plastic threads, so we'll have aluminum threads for the little screw because this is really tiny threads. So you orient this so that this little pin right here on the side, it'll actually drop into that hole, that offset hole from the center hole. And then once you get it in there, then you thread in your little tiny M3 by 0.5, yes, that's right, screw, which is right here. And it's super tiny, and I checked it with my thread gauge, and I went over to my start chart and I saw M3 by 0.5. My tap drill is going to be 2.5 millimeters or 0.984, and I grabbed I believe a 39 drill, number 39. Let's check in the drill index here. Yes, so I think, oh actually this is a 40. I went 40 because 0.98, it'll probably, the drill might walk a hair just a little bit, so it'll get right up to that 0.984, no problem. The reason I have the 39 drill, the 0.99 drill out as well, is because once you put this in and then you put the shell over, there's a little hole for a cotter pin to slide through, and that's what's actually going to hold the shell down, with 3 of those cotter pins on 3 of these mounts here. So my through hole is actually going to be my 39 drill and my 0.99 inch drill bit, and this is the 40. Number 40 drill bit, which is the 0.98. Here's our small little tap. Now keep in mind the M3 by 0.5, which you see there, be careful not to grab the M3.6, which would be your, I believe that would be your coarse thread for metric, and 0.5. The spacing will be tighter, so yeah, that'd be your fine thread. So we're doing fine thread here. And if you're curious, the Allen key head takes a 2 millimeter Allen key, and I can barely read that. This camera, I promise you, will not focus on that. But it does say 2 millimeter on that Allen key. Okay, what else to say? So we're going to raise it 5/16 of an inch so that when the shell sits on this top shoulder, the shoulder will raise it 5/16 of an inch or 0.312, so to give us that clearance. So that's what we're going to try. So you see the distance between the top of the top shoulder and the bottom of the bottom shoulder, which will be the smaller bottom shoulder here. Those two stock distances are 0.258. So we're just adding 312. That's how we get our 0.570. And then we might have to drill and tap all the way through because this is a starting tap. I have to see if I have a finishing tap, because with the starting tap you don't really get into the meat of the threads until about maybe here or so. So for clearance issues I might have to tap all the way through, but we're making this piece out of aluminum and it'll just be stronger, so I think it can handle it if I tap all the way through the top. The only thing I'm gonna have to show you guys later is the offset 100,000th thick pin that I'm making a little bit longer, 0.125 instead of the 0.082, because this, on the stock setup, if you drop that pin into the hole, it doesn't poke through to the other side. It's not flush. Let me see if I can do this with one hand here. You drop it in. Okay, so it's in. I don't know if you can see that, but it's right above the gold colored bar. It's not coming through all the way through that hole. So I can actually make it a little bit longer, and thus it'll be just that much stronger. So we're going to have an overall length of 1.058 inches compared to the stock 0.718. And this is what we're going to get going with. We have our lathe set up. We have our piece in the 3-jaw chuck. We have it sticking out about 1.25 inches because we're going to part it off. And I think what I'm going to try here is I'll actually machine the top section first. And then what I can do is I can part it off, then I can flip it around, and I can grab it on here and do the rest of the operations, because I'm going to be drilling and tapping from this side anyways. So I think I'm going to have to do it in 2 operations like that, and I won't be able to do it in just one. If I start here, then I'd have to get back in here and machine this back to it. I might, you know what, I might actually be able to do it in one, now that I think about it. If I just stick it out more, if I get my tool in on the backside and feed this way to skin this down to this 0.302 thickness, this might be a 1 operation job. Let's give it a shot. Yeah, actually, I'll just do it like that. And I have a plan for the pin, so we'll, I just got to figure that out, but I do have a plan. So we'll get started here. We're going to operate this in this orientation. We'll machine off our new upgraded blueprint and see if we can make that happen. Okay, so for our first operation, we'll go ahead and not knock over our setup here. We'll turn on, we'll face it, and then we'll do our first section, which is going to be, don't worry about the pin for now. I think I'm going to drill it and then press a pin in, because otherwise it's going to be way too difficult to figure out that setup. I'm sure there's a way. We're just going to machine back the 475 thousandths length, and that diameter is going to be our 0.480. So we'll go ahead and do these first 2 operations here. I'll just feed it in a hair on the big handle. Okay. And then what I'll do is I'll drag my tool out to just so the tip drags along the surface and I can see a mark and get the chips off here. Okay. Okay, so I got a mark on the face of my work here that's been faced off. I'll take my indicator and let me tighten this up real quick just so it doesn't move, the whole saddle. I'll butt my indicator up against the saddle, I'll tighten it out, and I have my 0 mark. And since I'm going to be machining this way, 475 thousandths, every full turn of this is 50 thousandths. So I'll crank it until I get to 450, which should be 9 times, and go an extra, not quite 25, because I want my finishing cut to be a nice face cut on that shoulder I'm going to create. So what I'll do is I'll butt this up again here, and while I hold it, I'll tighten down the screw here, which will clamp it to the lathe, to the way. And always clean out your chips there so you don't slip and cut yourself up. And if you tighten it, just make sure this didn't move slightly. So just take your dial and butt it up against there. Then you can 0 out. Okay, so we have so if I'm going screw down towards the bench to feed it this way, that was, okay, that's 5. We'll go 55. That's the second, I'll just count turns. That's the second full turn, 3rd full turn, 4th full turn, 5th full turn, 6th full turn, 7, 8, 9. Okay, so that's 450 plus the starting 5, that's 455. And then I'm gonna wanna go to, let's take it to 470, shall we? So we'll go plus 10 is 465, plus another 5. Okay, so right now it's on 470, maybe 469 and a half. So that means if I back this out, if I crank the saddle all the way over, let me loosen it first, all the way over to my stop, I should only be going 475 thousandths down my work. Okay, so my work, it's starting, this is a 5/8 piece of material of aluminum, so it's 0.625 thick. So we will go from 0.625 down to our 0.480 thickness. And I will just take, I might start with like 30 thousandths cut, just see how the machine feels. Check it with our mic, see if it's cutting a taper at all. And we got our oil here, a little zoom spout, so we'll start with a little bit of that. Aluminum is softer, sometimes I just get away with not using it, but hey, for the video, we'll get a little bit of a cooling effect there for our chips, and let's go. I don't know if you can see it on camera, but there's going to be a little bit of wobble in your work on any given 3-jaw chuck. It may not run perfectly true. Okay, so we got there, and then our dial here will feed in. It's on 10, so we'll go 20, 30, 40. And that should give us our 30 thousandths cut here, so let's see how it does. Take it nice and slow. We'll watch the chips. Chips are looking pretty good here. And again, 0.475 is not even quite half an inch. So keep that in mind. Okay, so that's our stop. Okay, a little bit of a rough finish there, so you can always switch your tools and whatnot, but we'll polish this up anyhow. So we'll verify that our length was not too much. Perfect, it's just under half an inch, so it's probably our true 469, and we'll take a measurement with our 0 to 1 mics, and you can roll them to open up faster on your arm. My top clicker doesn't really work all that much, so we'll just get ourselves a baseline here. We went from 0.625 down to 0.570 because it's 20 past 550 on the mic, so it's 0.570. All right, so we're going down to our 480, so we'll just keep it going. So 570, another 30 will take us down to, should be 540 or so, we'll see. All right. And of course the finishing cut should only be like 10 or 15 thousandths at the most. And that's how you get a nice good finish. And if the cut is too rough, you can always just take a little piece of emery paper, clean it up, polish it, then check your measurement. Okay, so we're down to 513. Oh, this must be a double indicator. So what if you feed in 10 and actually cuts 20? Because if I'm going from 570 to 513, I only fit in about 30 thousandths. I actually took almost 60. So it's a double on this one, so good thing we caught that before we cut too much. All right, so 513 from 480. Old school guys in the machine shop, they had just an old school calculator when I was working with them. Let me make sure you guys still focused in. Yeah, you're good. Okay. 513 and 480. 480 to get to 500 is 20. To get to 510 is 30. 33 thousandths is what we're off. So we feed in 15, we'll get real close to our 480 diameter. And let me just measure my stock plastic piece on that 480 just to double check. Yep, it's definitely 480. We're at 513 there. So let's see, if I'm going to go 33, I'm not going to take the full cut here. So what I think I'm going to do is I'll take 10. I'll feed in 10, which would be 20 on this setup. And then that'll get me real close. My finishing cut should be real sort of nice. And here is one of the chips. I don't know if you can see that, but it's making good chips. So we'll keep it rolling. Okay. Feeding in 10 on the dial. A little bit of oil. Oh, the chip's coming out of me. I'll actually back it out so I get a nice finish on this one, because I don't want to drag the tool back around when I'm getting real close. Look at that chip. Let's start selling these chips online like people be selling their farts in a bag and whatnot, those weirdos. But then people pay for it, so it's crazy out here. All right, let's see what we got here. We went from 513 to 475 plus 18. I'm trying to go to 475 plus 5. So 475 and 18, that should be 493. So I am 13 thousandths off. So if I feed in 6, that might get me right there. Now here's a little trick for you. I'm gonna feed in that full 6, but I'm only gonna machine the first section, and I can check out the mics. And if that's good, then I can take it the whole way. If it's too much, I can back it out or feed it in just a hair, depending on what I need to do. So I backed it out last time, so I'll touch the tool end. Okay, it touched it, and I'm going to feed in that 6 so that it takes 12 or hopefully 13. Okay, it's going to be real hard to see, but that first maybe 3/16 of the fit is machined down. And let me go ahead and check that. And if that got me to where I want, we'll just keep it as is. Oh, beautiful. We're at 481.5 thousandths. So honestly, we're just going to take that and we're just going to polish it with some sandpaper, emery paper. And then also too, I'm going to feed this back another 5 thousandths. So I go my full, what was it, 475, and then back it out to get that nice finish on the shoulder. So again, down to the bench to feed it out. We'll go another 5, lock it up, and we're already set on the crosswalk. There we are at the shoulder. I'll just go ahead and back it out. Boom. All right. And it might have actually fed in just a hair more. We'll see. I mean, really, I think if you want to go the technical route, it's best to grab it like this. Yeah, that's perfect. It's like a thousandth, a thou and a half over. So yeah. Okay, emery paper, where are you at? Okay, sweet. We got a nice little piece right here, and we'll always grab it like this so that it doesn't grab our finger and cause a bad time. We'll work our saddle way out the way. Turn the machine on. And if your emery paper has a string on it, rip that thing off. You don't want that getting caught up in the mix. So yeah, just like that, always keep an eye on your hands. Okay. Let's check this. All right, we're gonna go with that. It's perfect. Okay, and then the last thing I'll do is I'll chamfer this edge here. And then I do have to get going to work, so we'll pick this up later on. All right, come on down here. Take a look up close here with me. So we got our length, we got our fit, we got our little chamfer just on the very edge so that we take away the sharp edge. And then probably next what we'll do is we could drill and tap, or I can move on to the next fit. So we'll figure that out in the next clip. All right, time extended a little bit more time. I'll do one more operation before work. So for the next part, we're gonna do our 0.095, almost 100,000 thick shoulder, which is where the shell will actually sit on top of. So in order to do that, and then we're also skin it down to 550 from 625. So we have our tool stopped at our 475. So all we're gonna do is we're just gonna take it an additional 95 thousandths with the indicator that way. We have it butted up against here, and all I'm gonna do is loosen this guy. It's at the 20 mark, so if I bring it on down towards the bench, a whole 20 back to the next 20, that'll be 50. And instead of going 95, right? So instead of going to the full next 20, we'll just take it to the next 15. Another 45 plus a 50, there's your 95. So it'll go 0, 5, 10, 15. Or actually, you know what? I'm gonna keep it a hair away from 15, not quite, because again, that finishing cut, right? So I'm gonna leave it there. I'm gonna don my safety glasses, which I put over here. And let's just get right back into it. Okay, 625 to 550 is not a whole lot. Let's start with 625 to 550 is 75 thousandths, right? So if we start with 20, that'll take 40. Okay, so let's feed in 20. Okay. And let's check that before we go any further. Always check. And there's not much to grab with the mic, so just do your best, get a feel for a good measurement reading here. Okay, we're looking at 575 and 17. So we went 592 from 625. Okay, so taking it down to 550. 592, if we feed in 10, that'll be 20, so we'll go down to 572. So let's just feed in 10 and get after it. See what this gets us. This gets us 575 and then 2 under, so 573. Okay, 573 to 550. Let's take not quite another 10. Are we 23 over? 23 and me? Am I dating my sister? 573, don't date your sister. This is not Alabama. Okay, so let's take 5 for 10. Screw it, I'm going to take 8 for 16. Okay, now we got 558. So if I take 4, that should bring me home. So maybe the 20 was right. So I'll go, shoot, it's hard to see here. 1, 2, 3, 4. Okay, let's take that. Let's go. Oh, well, this is the finishing cut. We'll back it down. And we'll take our finishing shoulder cut as well. Okay, 550 and a half. I'm gonna go with it. Okay, we now have this fit turned down. We have this shoulder fit turned down. And all we have to do next is, I probably can work on this, turn that down, and then we can bore through the whole middle with our, what did I say, our number 40 drill, the 0.984, or the 0.98 that should turn into 0.984 if the drill wallows out just a little bit. So let's do that. But at this point, since I'm gonna have to machine back to the shoulder, my turning tool only cuts this way. So what I have to do is find another turning tool where the tip is actually facing that way in the holder, so I can come back here and machine back to this 550 shoulder we just took from the other side. So let me see about figuring all that out, and I'll see you guys in the next clip. All right, in order to do this next operation, I have to machine away basically this 3/8 section down from 0.625 to what is it, 363, going off my measurements here. Yeah, with the 0.363 for this fit here. In order to do that, I have to machine this away so I can have enough clearance to get the tool in there to skin this back. So what I'm going to do is I'm going to take my part off tool, I'm going to load it up, and I'm just going to, in between those marks, I'm going to skin it down far enough so that I can start to skin away the fit I need down to that 0.363. But I'm not going to go too far with the part off tool because I don't want to get the material too weak and have it start wobbling on me as I'm doing my machining work. So I think this should work. If I get this down to maybe 0.400, maybe that'll work, and I can do my thing and get in here. That's still 3/8 thick on the material, so that should be fine. And I can do my thing, and then I can drill and tap. Or I might drill and tap first, just so that I don't have any problems with the material walking from it being weaker at this section. So yeah, you know what? I might go ahead and drill and tap first. So I already have my center drill. All right, the phone ran out of storage, typical. So we have our little countersink in here with the tip of it into the back of our tiny little tap handle, which is grabbing onto the tap, which the starting tap is in our drilled hole. And we're just gonna carefully feed this in as we turn the tap handle. And carefully oil up the tap. We're gonna carefully tap these threads because they are probably the smallest threads I've ever tapped. And then we'll see if the bolt goes in the threads and holds. And with a little compressed air, we can blow out the chips. And then will she focus on camera? Oh, maybe not. Maybe this is a zoom and enhance. Wow, it's too small. Oh, maybe not. Do we see threads in there? We're gonna keep tapping and try our screw, make sure it fits. All right, let's see if that focuses. So day 2, we're gonna machine out our fit with our part off tool like we said, and then we'll have clearance to come in and machine the rest of our piece. Clear out your chips and get back right to it. A little bit of oil, you said? Is it squealing? Alright. No problemo. Alright, it's going to be a lot more of that until I get it down to about 400 thousandths or thinner. So then we can go in with our tool and machine this fit down that we need to get to. Alright, we got the back machined out. So our turning tool can fit in there. And now we can machine this fit out. So we're going down to 302 thousandths as per our little blueprint here, 302 thousandths thickness. And we know that the thickness of our big shoulder is 95 thousandths. And I left a little bit, it actually came out to a little bit extra. I got lucky with that. So it's actually a hair over that. So I can actually machine up to it, and then we can measure that and then face off from this other shoulder, this back shoulder, to get it down to 95 thousandths. So we can take this fit down to 302, and let's just get it going. I'll set you guys up here. You get a slightly different angle. I'll give you a little, how about I give you a little 1.5x on the zoom. Again, it's no 4K quality, but it's something. So I'll load up some oil. I got the tool to the center of the work, not too high, not too low. And it's not going to hit the chuck jaws either. I think we're good to go. We'll get a measurement there, and now that both shoulders are exposed on the big shoulder, I can also get a measurement here. Big shoulder is about, it's about 80 thousandths now. All right, you know what? We're not going to machine any more into it then. 15 thousandths, a little too much, but I think it'll still work. Where are our 0 to 1 mics? Because we raised the peak, we only thought initially we had to raise it up 1/4 of an inch. It went 5/16. So 312 minus 15 puts us back to 297. So that should still work. And our 302 fit here. Is down to 450 plus 16, 466. And we may have to come in more than I thought with the part off tool. I don't want to come in too far because I don't want to weaken this section and my work start to wobble and run it out of true. Yeah, that's looking like the case. Okay, so we're going to go some more with the part off tool here, and then we'll keep machining that fit back. And let me bring you right up close here. You can see that, so this thickness is now 80 thousandths, but again, I think it just still work. And we'll keep on going. Okay, we got our fit, our 302 here. We'll polish it up a little bit, and now we're just gonna run the file on either side of our shoulders here. Make sure those have no burrs on them, and then we'll be ready to part it off. So come in close there. We'll just get that edge off. Same thing on the other side. Just took those edges off right there. All right. So for the pin, we will have to flip it around. I was trying to do everything in one operation and one setup on the lathe, but just can't quite. But fear not, we have a plan. Also, our length of our 302 fit is going to be 363. So I'm going to come in here with the scale and just go a hair more. So 1/8, 2/8, 3/8 is 375. And I'll put a mark there. And then we want to mark it so that we cut, or we part off a little past 363 so that we can come back and face it. And that will be that. Okay, so we'll come in here, we'll line it up. I'll cheat a hair past the mark just to make sure we're giving ourselves enough length to part off and to face. And now if we tried to machine on that, the piece would be so weak it would start running out of true and wobbling. Okay, almost there. I'm not going to try to catch it. That just wouldn't be safe. Come on now. I never did that at the machine shop back in the day. Boom. Okay, I just dropped down in our tray. And would you look at that? Drilled and tapped. We got our 480 fit. We got our 550 fit. We got our 302 fit. This is already to length, our 475, I believe. And then we'll chuck it up. We'll grab it like this. We'll face this. And then only then can we flip it around. Oh, okay. Yeah, I'll tell you what I'm going to do about the pin. But for now, we'll chuck it up, face this down to our 363 length, and we'll show you about the pin. Okay, side quest. Hear me out. It's gonna set me up if I have to do this, make another one of these, or 2 more, 3 more of these pieces. We got the 4-jaw chuck set up. We got our center drill. We're going to machine into a square piece of material, and we need to grab the round material on this 302 fit in order to machine our offset hole. So a good way to grab it, and I don't want to damage that fit either, because that's our finishing look. I'm going to machine into this block, or I'm going to drill into it, and I'm going to drill similar to a 302 hole and I'm gonna split the block with a cutting wheel. Then I can grab the block in a tool post, and that way the square will clamp down onto the round material. It won't damage the fit at all, like a set screw from a tool post digging in to our aluminum fit. And I can grab on a 2 flats instead of on a round, and it'll just be way better. So we're side questing here, but it's for the purpose of grabbing this. That way we don't have to worry about our piece walking or moving when we're machining into that offset hole. All right, we'll just give it a nice little countersink. Perfect. Unlock this, bring the tailstock back, and there you have it. It's drilled through, and we kind of got this just where we wanted it because our fit just barely doesn't fit yet. But once we take a cutting wheel to one side and split this piece, it'll accept this fit, and then it'll clamp down nice and tight. Okay, we practiced filling out a hot work permit last night, so we should be good, right? Let's go. It is slow work, but it is going. Okay, we're super close. We're super close. Can you guys see that? Super close. So be careful using those little 1.5 inch cutoff wheels. But she's through. We'll file it down and we'll do a test fit after it cools down, of course. All right, gang, back at it. So we got our piece back in the milling head attachment because look, we did our split. Our aluminum piece that we want to grab on the round here, it fits in there because when I did my split, then it clamps down on it when I grab the split in between two vice jaws. But the piece I need to grab in the tool post, would you believe the tool post is 545 thousandths, and my piece is 9/16, 562. So I can't fit in here. So what I gotta do is I gotta mill this down another 20 thousandths. And I have just enough stick out here because I got it squared up against a piece sitting in the back there. And then once I do that, then I can slide this piece into the hole, then clamp it on here, and then we can do our offset hole. So a lot of extra steps you don't realize till you get into it. Now, I drilled in with the end drill, which is a 302, but my piece is a 307 fit on my thickness here. So it wasn't quite fitting. So what I thought it would open up once I split out the cutting wheel, but just not enough. So what I did is I went halfway through the bore. You can see kind of a little split there in the middle, a little smaller shoulder. So I went halfway down with a 5/16 drill bit, and that opened up a little too much. It was a little too much slop, but I loaded it up in the vise here and I clamped down with the split facing down, and I closed it down just enough so it's a snug fit for the piece is sitting there, and then it'll clamp down tight once I clamp it down in my tool post holder. But yeah, we're just gonna take off 20 thousandths here right quick and then continue on. All right, where's the oil? Where's the oil? Show me the oil. Just a little dab there. Lay this plugged in. This is tight. This is tight. This is tight. I got loose play here. And let's get, oh, never forget, make sure your stop has been released. That could have been a bad day. You do not want to be having bad days. Come on now. Make sure you have free spin. Very nice, very nice. Okay. All right. Gonna have to grill some burgers after this and wake up. Let's touch it. Let's walk it out. Doesn't matter which way on a facing cut. Oy vey. Let's bring our little indicator stop here. Okay, touch it to our saddle. It's at 11, so it'll come down. 20 is 9. 30 is 19. That'll put us at 562 minus 19 should be 543. That should barely work. That's hilarious. And I've squared up the milling head vise to the collet holder with my scale. Checked it on either side of the end mill. And got it pretty dead on. Okay, that should be all we need. It left a little lip on the bottom that we can grind that off. Do we want to go an extra 5 to be sure? I don't want to crash into my vise here on my milling head attachment. I could go like another 2 thousandths. Let me if I lefty loosey, it brings it up. So we bring it up just a hair. Let me get that little lip off on the bottom there. Yeah, let's go 2 thousandths. Wow. Couldn't have gone another thou or two. Okay. Release it from the vise. Bring it out. Let the file off the edges there. Do we have our little sander? Oh my gosh. Doing it live. Unplug this. Take a little sander here. Just like that. Nice and sanded off. Okay. Tool post. We're gonna want to see the split, how it's on the left. With our tool post, we're gonna want to grab it towards the, and then we can flip it because we have a smaller bore and a slightly bigger bore. Oh my gosh. This looks like it's caught a little burr there, so it's close. Seriously? Ha! We are like, oh, never mind. We're good. Look at that. Look at that. Machine precision. And now when we tighten down these 2 set screws, it should clamp that down. And then it should grab our, oh, that's the small side. So you see I did a small side there. And then a big side here. Boom. So that's what I'm going for. Then I can drill my offset hole, and it should be long enough where both set screws can get a grab on it. Boom, boom. All right, on to the next step. All right, a little pin action. So we have our center drill in the collet. We have our piece in that little setup with the split, so we can clamp down and grab the piece. We have it sticking out of the tool post just a bit. And what I did is I just got the tool post at the correct height to slide over the center drill and the correct in and out. So I pretty much have it centered up as best I can. And then I need to know where to spot my hole from the center. So the thickness for a piece is 480. The center of my tapped hole to the end of the piece is 240, half of that. And then the pin on the old one is not quite all the way to the edge. It's about 10 thousandths in. So I'll take the 240 minus 10 for 230. And I'm going to take half of my thickness of my pin because I want to drill in the center of it. So it's going to be 50 from 230, 180. So since I have this centered up as best I can with the hole, I'll just crank the saddle that way, 180, and I'll spot it with the drill bit, and then I can drill it out with my .99 drill bit. Just about, I don't know, we could go 3/8 of an inch or however much we want into our piece. And then once I do that, I can take some various aluminum material here, and I can turn it down, probably the thinnest one I got, turn it down to .99 or .10 so that it can be a press fit and have it stick out that .125, and then it should fit into this offset hole. Actually, it'd be this smaller hole is the offset hole where that pin needs to drop into, and I can test fit it. You see, I've already gave it a little spot. This makes or breaks the piece right here. Just take it in with the center drill very carefully, right on the edge of that fit. All right. Wow. Look at that, right on the edge of that fit. So we'll come in with our drill bit, go as deep as we need, machine a piece to press in there, and then we'll test fit. In no way we got lucky with a 3/32 collet to hold our drill bit. That is a big win, because otherwise I would not have known. Had to figure out a different way, I guess, to grab my drill bit for this next operation. All right, we got our main piece chilling over here out of the way. We got our turning tool back in the quick change tool holder, and we are machining our 1/4 inch aluminum rod down to .100 or thereabouts. I just checked it with the 0 to 1 mics. I am down from 250 down to 189, and as this piece gets thinner and thinner, I'm going to take nice and light cuts. Don't want to knock the piece out of true by taking too heavy of a cut. So we'll just keep it careful, and we will machine down so we can press fit into that offset hole, which we drilled out with the .99 drill bit. Let's see if we can't make this happen. And it looks a little bit longer than what you would think I need, but remember I have to part it off, so it's going to take away some of my length there. So let's feed in on the dial just another 5 or so, so that'll take 10. Kick our lathe on, and I have the stop set up right here so I won't crash into the chuck. And here we go, just gonna take a nice light cut. We'll do it for you live. Guess I can probably take more than 10, maybe could get away with 20. Right there to the shoulder, work it back out, and I'll keep it on going there. All right, so cut a slight taper. So out here, I'm measuring 105, and then right at the mark, I'm measuring more like 101, and then just past it, I'm measuring .99, .98. So we can actually, I'm just gonna sand off this close down to that 101, 100, and then we'll part this side off, and then this is the slightly skinnier side, that side will press in, and then it'll start to grab the fit somewhere around here. Or I could just sand this down and press this side in, and this side that's slightly, just a half a thou or a thou under 100, that could be for our drop-in pinhole. All right, we got it. So you have to be so careful when you're turning down at this thin of a diameter, because as I brought the tool in to cut another 2/1000ths, as soon as I touched the tool here, I could see the piece bow out this way as I was putting pressure on it while the lathe was turning. So you just got to be so careful, because you don't want to break your piece or break your tool cutting down at these thin diameters here. So I just carefully fed in the saddle real slow, got to about here, went back out, because my back fit is still good, but I couldn't sand down 6/1000ths. So I just turned it down a little more, sand down the whole thing, and it is ready to go. So I could use the part off tool, but it's so thin I could probably just use a handsaw if I could find one. Just get it, cut it off back there. So the Saws will be going crazy with the blade in the sawzall. The part off tool might bend this or might have some issues, so why not just grab the blade with 2 hands and saw it from the 6 o'clock position of our work and just go right through it. We've already gotten halfway through, and we have to flatten the blade up against the flat of the material that we didn't turn down that's slightly sticking out of the chuck. Just like that. Sometimes stuff just be easy. Can you see that? It's real small. So we're gonna press that into our piece. Make sure it sticks out only 1/8 of an inch. For our, let's get the diagram back out. Yep, per that 0.125 stick out. All right, so we got our marked side of our offset hole, and we'll make sure it fits in there nicely. Like a glove. See how it comes out flush to the other side? And this bar kind of acts like a stop also. And then before we put the opposite side press fit, we know this is a touch skinnier, so we'll make sure it slides all the way in and only has a 1/8 stick out, like a glove. Put the scale on it, and as you can see, it just doesn't get much better than that. Okay, let's press it in, and then we'll test fit the whole piece into our bracket. And then the only thing left we have to do is drill that through hole on the skinny fit in there and make it in line with our pin. And the test fit is a big success. Nice and flat against the bracket, bolt is in, pin is lined up. Thank you very much. Okay, since all that is out the way, the next step for the through hole with the 0.99, that's going to be a number 39 drill bit. The through hole, I think I could just grab it on the 480 fit and do my through hole. Da 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 da. How do I want to do this? I would have to put my drill bit in here and then get my piece mocked up in here and bring the piece into the drill bit, probably so. We'll figure it out. Okay, and finally for the pinned hole. So the hole has to be, or the pin has to be parallel with this hole. So I have my piece back up, just chucked up in the lathe, just to hold it kind of like my vise. You see my pin is there. And if my pin is sticking out straight back, I put a mark so that my hole is in line with that pin. If the pin is at the, what would you call this? The 9 o'clock position. So that way I can go straight down with my pin. So I just marked a reference point on the big shoulder here. And then since it's 0.195 from the top for the center of the hole, excuse me, I just took a scale, roughly marked it just past 3/16, and then I'll hit this with a punch and just drill through it. And then that'll be, this doesn't have to be absolutely precision. I could, you know, take off the 3-jaw, put my center drill and the collet in here, put this piece back in the milling head attachment, but then I'm having to grab it sideways and maybe grab it only on the flat here, a very thin part, and then I risk it moving around. So I can maybe grab it on the thick part back here, but again, since this doesn't have to be absolutely aerospace precision, we could just do this and hit it with the punch, drill through, and then we'll be doing a test fit in the very next clip. Okay, so here's the RC car all put together, test fit the shell. We got the aluminum pieces poking out, and you got the clearance now between the shell and the hardware underneath the shell. And you see the spacer at work there. He can pin it on the bottom if he needs to, but the press fit's holding up just fine. And the cotter pins will hold the shell down from the top. And then we'll do 3 more RC cars just like this with the rounded tops. And that'll be that.